You've seen it everywhere, right? AI that can write an essay, paint a picture, or even make a video. But what if I told you the next giant leap in artificial intelligence isn't about generating anything at all? We're going to dive into a pretty fundamental shift that's happening right now. A move away from AIs that just talk and towards AIs that can actually understand. But before we get to the future, we have to talk about the present. And we need to ask a question that honestly gets swept under the rug a lot. Why are the AI models we use every single day so inefficient? There's this hidden bottleneck in how they operate, and it's holding back some amazing progress in things like robotics and real-time AI assistance. The core of the problem is something we can call the generative trap. Think about it like this. To prove it understands a video of a pot of boiling water, a normal AI has to be able to basically paint the steam. It has to generate every single tiny irrelevant pixel, just to show you it gets the big picture. It's like asking someone a simple yes or no question and then having to wait for them to slowly type out a whole novel, word by agonizing word, just to get to the answer. It's kind of absurd. And this trap comes with some serious baggage. 3 big problems. First, it's incredibly expensive computationally speaking. It's just burning energy and compute cycles on details that do not matter. Second, it's slow. Generating token by token is a killer for anything that needs to happen in real time. And finally, it's a big reason why these models hallucinate. They're basically forced to make stuff up just to fill in the blanks and complete a pattern. So you're probably wondering, how do we get out of this trap? Well, the answer isn't a small tweak. It's a huge, fundamental shift in philosophy. It's about moving our focus away from just words and pixels and toward the real heart of intelligence, understanding abstract meaning. Okay, this slide really breaks it down. On the left, you've got token space. This is where today's big language models live. They're obsessed with grammar, word order, and predicting the very next word. So to them, the sentence, "a dog is running and a puppy is playing" are, totally different things. But now, look at the right. This is semantic space. Here, it's all about the meaning, the concept. And in this space, those 2 sentences are almost identical. And that is the key. Current models predict the next word. This new way of thinking predicts the next idea. And this isn't just some fringe idea. This is coming from AI pioneer Yann LeCun. His whole argument is that real intelligence isn't just a fancy language game. It's about building an internal model of how the world actually works. Language is just the tool we use to talk about that understanding. So this all sounds great in theory, but how does it actually work in practice? Let's take a look under the hood at the machine that makes this happen. Meta's new architecture, called VL-JEPA, is really the first major example of this predictive approach. It's built from the ground up to predict meaning, not just words. So the key thing to get here is that VL-JEPA is non-generative. It's not sitting there painstakingly putting a sentence together piece by piece. Instead, it forms a complete thought, a concept, about what it's seeing or hearing. It learns what an event means, instead of just learning the right words to describe it. The whole system works kind of like a tripod, which is a really neat way to think about it. First up, you have the eyes. This is a vision model that just watches a video and boils it down into a summary. Then you have the brain. This part uses some layers from Llama 3, and it takes that visual summary, combines it with a question, and then predicts the thought of the answer, basically as a chunk of data. And finally, you have the target, which, during training, gives the brain the correct thought to aim for. Simple as that. And this is the truly genius part, especially for efficiency. The model can think, it can reason, all without using any language at all. The mouth, which is just a small, lightweight text decoder, is completely optional. It only gets turned on when a human like you or me actually needs to read the answer in English. The model doesn't need to talk to itself to think. Let that sink in. All right, so does this wild new design actually deliver? Let's get to the numbers because, honestly, the results are pretty staggering. This isn't just some theoretical improvement on a whiteboard. It is a massive, measurable leap in performance. Let's start with the need for speed. By not being trapped into generating text all the time, VL-JEPA gets a nearly 3 times speed up for things like real-time video captioning. And it does this with a really clever trick called selective decoding. So how does that work? Basically, the model just stays quiet until it actually sees something meaningful change. Take a look at this chart. The highlighted row, the adaptive strategy, shows that you get almost the exact same quality as describing every single frame, but you do it almost 3 times faster. That's the sweet spot. And it's not just faster, it's a way, way smarter learner. This number,
43 times, that's a massive jump in what we call sample efficiency. See, when you're predicting abstract meaning, it turns out that's a much more direct path to understanding, so the AI learns a whole lot more from way less data.
And this table is the proof. Just look at that bottom row. On these action recognition tests, VL-JEPA gets the best accuracy. Okay, impressive. But now look at the column next to it, sample scene. It achieved that top score after seeing 43 times less data than the next best model. It is just doing so much more with so much less.
Okay, so a faster, more efficient AI. What does this all really mean for the future? This isn't just about making a slightly better video captioning tool. No, this is about laying the foundation for a totally new kind of artificial intelligence.
What we're seeing here is the first real concrete step toward building what people in the field call world models. These are AIs that don't just, repeat facts they read online. They build an internal, predictive simulation of the world. They actually develop a kind of common sense about physics, about cause and effect. And the applications for that are absolutely game-changing. We are talking about robots that can anticipate that a glass is about to fall off the counter and catch it. We're talking about real-time AI assistants in your glasses that understand the world around you without draining the battery in 5 minutes. Or even autonomous cars that can plan for complex situations because they can actually predict what other drivers are going to do. And here's one final piece of proof for you. This is a test for causal reasoning, basically understanding what caused that to happen. And look at the results. VL-JEPA, with its tiny 1.6 billion parameters, just dominates. It beats massive frontier models like GPT-4o by over 10%. It has a better gut feeling for cause and effect. It's incredible. Now, hold on, this doesn't mean large language models are going away. Not at all. In this kind of future, their job just changes. They stop being the entire brain of the operation, and they take on a new, really important role. They become the language layer. They're the translators, the interface that takes the world model's deep, complex understanding and puts it into words that we can actually comprehend. So, all this leaves us with one big final thought. For years now, we've been measuring AI progress by how good its generations are, how pretty the art is, how flawless the text is. But maybe the real revolution won't be generated at all. Maybe it'll be about building machines that can silently, efficiently, and accurately predict the world around us.